Here we are in the second part of cells. And this first lesson is over homeostasis and cell processes. The essential question is, how do organisms maintain homeostasis? So our standard is S7L2, and that was what we were in last time. And like every lesson, you're going to start off with an engage your brain section. So on page 175, you have a few questions. And the first question asks you, how is this person able to stay on the skateboard? How do they not fall off? Second question asks you to fill in the blanks with a word or phrase that you think correctly completes the following sentences. So you have 3 sentences there. And then number 3 is one of those learn the word active readings. Sorry. And so you have the word broken down into parts, and you have a sample sentence. Whoopsie. And so they want you to look at the table and the sentence and come up with a good definition of photosynthesis using the context clues in the sentence I've given you. And so the first part of Lesson 3 is called Stayin' Alive, and we've had a lesson called Stayin' Alive before, and hopefully you remember John Travolta. I do have to play a little bit. That disco scene is one of the scenes that helped make John Travolta famous. Okay, so in looking at homeostasis, one way we keep homeostasis is by obtaining and using energy. If we take in too much energy and don't lose it, then our body stores it. If we use too much energy and don't take in enough energy, then we're in trouble. So here is an amoeba taking in some food. It is ingesting 2 parameciums. And the parameciums are like, oh no, we're being caught. And so obtaining and using energy. Another way is by making new cells. Animal cells and plant cells undergo mitosis, or the cell cycle. And we will be going over mitosis and meiosis in their stages. So both plant and animal cells undergo mitosis. And then on this cell, you have an animal cell on the left and you have bacteria on the right. So the animal cell has to go through several stages before it can duplicate into 2 new cells, versus the bacteria, you can see how fast it goes. So for multicellular organisms and eukaryotes, it's a little more complex of a system or division. The exchange of materials. So we have to take in food. Oops. Or get rid of our waste. So once this amoeba eats these parameciums, he'll have waste from that. And you can see up on the left, you can see gas exchanges between the alveoli in the lungs and the red blood cells. It's just an animation, it's not real. And so the darker colored blood cells are ones without oxygen. And as they go by, the oxygen is diffusing and making the red blood cells full of oxygen again so they can go out and deliver that oxygen to where cellular respiration is occurring. So here is the top is scanning electron microscope and the bottom is transmission electron microscope. Whoops. And you can see this cell taking in materials. So you can see it, the cell membrane is wrapping around this to take it into the cell. And then when it gets in, it's going to look like this. It'll be pinched together here. And then elimination of waste. And you guys may not be aware, but we do some funny things as humans. And so there is such thing as cow patty contest to see who can throw a cow patty the farthest. So up here you have cow patties that have been dried out and are being sold. Here you see a cow patty that's kind of fresh. They're not going to throw this cow patty. You're going to wait for it to dry out before you throw it. And then here's some people down here at the bottom picking up, choosing their cow patty to throw. So this is the cow's waste. Once it dries out, us silly humans have come up with a game, especially in farming communities, called cow patty throwing. So I'll just play snippets of this. Okay, so I will confess that I have thrown cow patties. In my hometown, we have a little contest also. So it's a bit of fun when we're talking about elimination of waste. But organisms do have to get rid of waste. If they did not, then those waste would build up as poisons and the organism wouldn't live very long. So here is an example of paramecium undergoing exocytosis. And I put an arrow so you could see it better. I'll play it again. So the paramecium is getting rid of some of the cell waste. Hopefully it'll play again here. So all cells, even unicellular cells, have to get rid of metabolic waste. So question number 5 asks you to choose one of the following, whoops, and research how it works. You don't have to do this, think outside of the box. But if you want to, it would be a good learning experience for you. But for our lesson, you don't have to do it. Number 6 wants you to list 4 things that cells can do to maintain homeostasis. And I wonder if we just talked about them. I'll get back to you on that. I'm still thinking about it. Number 8, I want you to, as you read, underline how unicellular organisms and multicellular organisms exchange materials.